Assalamu alaikum. This is Dr. Usman Pracha, and today we would be going through our lecture number 14 of the subject Applied Quantitative Analysis and Practices. So previously we had a discussion on how to build statistical models, what's the process behind building a specific model from real-time situation, and in case most of the practical world models are very complex, the practical situation is very complex, so it's not possible to exactly frame the model as per exact real-time requirements or as per real-time scenario. So basically we discussed about that there are three basic categories of evaluation of that model, whether it would be a poor fit or a medium fit or a good fit. So basically there is not a perfect fit which would be existing for a model, because any variables which are acting in a real-time scenario in any kind of situation which a business organization is trying to assess, that situation would be including innumerable variables, and all of them cannot be taken into account in a statistical model. So we try to build a statistical model as close to the reality as possible, and that's why this whole exercise of conversion of these intangible measures and intangible phenomena to tangible measures has taken place. Though successful efforts have been made, but up till now complete conversion of a scenario or an organizational issue into a statistical model which would entail each and every minute variable impact on the situation has not been possible. So we have been trying to make these models as close to the reality as possible, and therefore in order to do so there's a specific process which basically is named as model formulating process, and in which we basically observe the phenomena which is taking place. That observation can be of employees leaving the organization, or it can be any kind of conflict within an organization, and then we try to see how to convert our observation into a theory, and how we can generate a theory from that aspect. So once we have generated a theory, though it is not necessary that it will be accepted everywhere in every sector or in any industry, so that's why once that theory is generated, then we basically try to identify the main layers and to identify the variables, and once we have done that, then we try to measure those variables, and once those variables measurement process has taken place, then we collect the necessary data and try to analyze that specific data. Once that data is analyzed, then we draw upon conclusions, and we try to see whether those conclusions conform to the theory which we have generated. Likewise, the theory which we may have presented and may have proved that this theory is valid enough in our study, which may be confined to some specific industries or a single industry, it would be tested by other researchers in other scenarios before it is generalized and formulated in a formal manner, in a formal literature. So basically this was the general model formulating process which we discussed, and the important component extracted from that model was the testing of hypothesis, because once we generate the theory, then we have to generate hypothesis, we have to make hypothesis, we have to assume things related to that theory, and once we have assumed these hypotheses, then we test that hypothesis through that data. So without the hypothesis, this theory part cannot be formalized, cannot be made tangible. So that's why the only way we can basically convert a theory into a more tangible form, into a measurable form, in order to do that, we would have to generate the relevant hypothesis. So in this case, we discussed that basically there are two types of hypothesis, and one type is null hypothesis, the other is alternative hypothesis. And in null hypothesis, basically we stick to the main statement or the main claim which we are trying to make. And once we have done that, then alternative hypothesis is the negation of the null hypothesis. It's totally opposite to the alternative one. And then we have to test both of these hypotheses in this case. Well, after testing that, and in order to test these hypotheses, we have to ascertain certain critical values. Obviously, as we have discussed before, that it is important that the data should be in normal position, and so that we can have a normal distribution. Once we have normal distribution, then we can ascertain the critical values which would be different in each kind of different tests which are made. And for example, there is a z-test, then there is a t-test in this case. Z-test basically is applied when we have got certain conditions available in order to test the hypothesis, and the critical values basically are ascertained based on the type of test which would be made in order to test these hypotheses. So these critical values that we have discussed before help us in identifying whether the values which are being tested fall in the rejection region or non-rejection region, and based on that we accept or reject the null or alternative hypothesis. So we have issues regarding errors, as when we are trying to measure these hypotheses or test these hypotheses, there is always a possibility that we can end up in an error. We may end up in accepting the hypothesis when in actual sense that hypothesis may not be true. So in this case we discussed about the various errors which were regarding type 1 and type 2, and then we had a brief overview of hypothesis testing for the mean. So these were the different topics which we discussed in previous lecture, and we would now go ahead with the same hypothesis testing. So just to have a recap of what we did before, in this case we basically decided about when would be the case if we do not reject H0, and if H0 is true, then obviously there would be no error as shown here. But if we reject H0, then in that case we end up in type 2 error, which is important here. And if we reject null hypothesis and H0 is true, then we ended up in type 1 error, as you can see here. So no error would be there if on the other hand we have rejected it and in reality the null hypothesis is false. So these were very briefly possible hypothesis outcomes which can happen. Obviously we have discussed before that both the types of errors cannot happen simultaneously. So here basically there are two situations basically here. like in which we know the standard deviation of the population, and in that case, if we want to test the hypothesis for the mean, we would have to commence with the z-test. Likewise, if the standard deviation is unknown, then we have to go ahead with the t-test. And now the various steps basically which are involved in the testing of hypotheses are that first you have to state the null hypothesis and alternative hypothesis. So null hypothesis basically is the negation of the fact that there is no effect of anything. If, let's say, we are saying that employee training impacts or influences the employee productivity, so in that case the null hypothesis will be that employee training does not impact employee productivity, and the alternative hypothesis would be the opposite to that. So basically in stating this null hypothesis and alternative hypothesis, we complete the first step. However, in the second one, we have to choose the level of significance, that what is alpha. And here, as we discussed before, we have to decide whether the probability level which we are going to assess, what would that be? So would it be 95%, would it be 99%, or would it be 90%? So this level of significance has to be determined from the very start of testing the hypothesis. So then again we have to see about the sample size, which is represented by small n, and going ahead with that, then we have to choose the appropriate test statistic and sampling distribution. So again, the appropriate test statistic would depend upon whether we know about the standard deviation of the population or not. Normally, in reality, we do not know the standard deviation of the population. So anyhow, in the fourth step, then we have to determine the critical values that would divide the rejection and non-rejection regions. So if you are commencing with the basically two-tailed test, then basically critical values on both sides comprise of 0.025 on one side and 0.025 on the other, and in total basically we are dealing with 0.05 value if we are trying to assess a directional hypothesis. So once we have gone through the critical values determination, then we collect the relevant data and we compute the value of the test statistic. And once that value is basically computed, then we have to decide about what would be our conclusion based on the value of that test statistic. Now if that test statistic, as we have stated, falls in the non-rejection region, then obviously we accept the null hypothesis. However, if it falls in the rejection region, we have to then reject the null hypothesis. So based on that acceptance or rejection of the null hypothesis, we have to draw the conclusion which are related to that real-time phenomena. So basically these are the generic steps which are taken in order to test any kind of hypothesis we want to test. And then here's just an example of how to test a standard hypothesis, and here we can see that we have just claimed that a true diameter of a manufacturing bolt is 30 millimeter. Now here in this case we are given standard deviation of the main population, which comprises of the manufactured bolts here in this case. So standard deviation here is given as 0.8. Now going ahead with the step 1, we have to state the null hypothesis and alternative hypothesis. So we state that H naught here would be comprising of mu is equal to 30, which is the main hypothesis which we are making. Then in case of alternative hypothesis, H1 here would comprise of mu which would not be equal to 30, that is, it is opposite to the null hypothesis here. Now here it is already stated that it's a two-tailed test, so we are not giving any direction. We are not saying that mu would be greater than 30 or less than 30, so when there is no direction involved, then we would be commencing with the two-tailed test. However, if we are basically giving a specific direction in our alternative hypothesis, then we would be commencing with the one-tailed test here. So here we have specified the level of significance, which is 0.05 or 95% confidence interval, which is the normal level of significance taken in business administration studies. Then n is 100 basically, so the sample size would be 100, or 100 manufactured boards are being taken for this test. And then commencing with the next step, as we know about the fact that here the standard deviation is known, then in the third step we choose the appropriate technique, which would be the z-test in this case. Now that we have ascertained that z-test is the appropriate technique, then again we have to determine the critical values, and following, in order to find out the values, we have just tried to find out the z values for alpha equal to 0.05 or 0.025 and either end. So here the critical z values would be plus minus 1.96. Here, as we know from that factor here, that in a standard curve here, let's say basically for alpha equal to 0.05, that means that one end of critical value would be 0.025 and 0.025 on the other end. So we would be determining the z values for 0.025 at the positive end, and then the z value for the negative end, now which have been determined as plus minus 1.96. So here you can say that 1.96 is the z value, which represents 0.025, and minus 1.96 for which would represent the value of minus 0.025 here. So the determination of that critical z value is important, because these critical values differ from test to test. So in case we are trying to evaluate or applying the t-test method, then these critical values would become different. Now once we have gone through that, we then go to the process of collecting the data, and then we compute the test statistic. So now here we are just given the example of sample results. For example, here n is 100, as we have discussed before, and the mean or x bar of manufactured headboards here is 29.84. Now here we already know about the population standard deviation, so we have got the formula for the test statistic here, which is represented by z-stat, and here you can see the formula which is comprising of x bar minus mu divided by standard deviation divided by under root n. So we basically put all the values in the formula, and we get the value of minus 2.0 here. So here we have been given a specific value for z statistic, Now we have to find out whether this specific value lies within the non-rejection region or rejection region. So in order to do that, we just draw the diagram here, and as you can see here, we have got two ends here. One is this positive one and the negative one, and we have identified the regions, and here you can see the middle region, which is comprising of all this middle white region. This is the region in which we do not reject null hypothesis. So if our z value comes in between this region, then we will not reject the null hypothesis, and in fact we will accept that. So here we have also underlined the relative z values of the level of significance. Now when we plot our z statistic here, so it comes in the rejection region here, as z statistic is minus 2.0. Now here this value is less than minus 1.96. So now here the z statistic lies in the rejection region. That means that we would have to reject the null hypothesis. So here then we have to draw upon the various conclusions here, because here as you are seeing that as this minus 2.0 is less than minus 1.96, we have to reject the null hypothesis, and we have to state that there is sufficient evidence that mean diameter of the manufactured bolt is not equal to 30. So we may not be able to give a certain number, but we can say that it certainly is not 30. So that's the nature of the prediction we can do based on these hypothesis testing. However, for certain a specific figure still cannot be given, reason being so that after all we are again applying this hypothesis test on a sample and not a population. So it may be possible that we take some other sample, then the results can be different. So once we have gone through this testing, now the concept which we see very frequently in SPSS test results is the p-value. So the p-value here is basically the probability of obtaining a test statistic which may be equal to or more extreme value of the observed given sample value, given that H naught is true. So here p-value is also called the observed level of significance. Basically the expected level of significance obviously is 0.05. So here p-value gives us the observed level. Again, it is the smallest value at which H naught can be rejected, but basically in shorter terms p-value just gives us the probability of whether we can have 95% or 90% confidence in reporting our findings. So based on that p-value reporting, that specific hypothesis is accepted or rejected. So now basically here are the basic formulas, like if we compare the p-value and it's less than alpha, then we reject the null hypothesis. However, if p-value is greater than or equal to alpha, then we do not reject the null hypothesis and we accept that. So again here the key point is that if p-value is low, then H naught must go. But here we must see that in, let's say in SPSS, basically in SPSS what we do is that this p-value is compared with 1 minus alpha basically, or 0.05. So basically in this case when this p-value is less than 0.05, then we accept H naught. So here basically in SPSS things are a bit opposite. So once we go through the next part, again what's the 5-step approach in hypothesis testing, and here again we see the same steps, that we have to state the null hypothesis and the alternative hypothesis. We have to choose the level of significance and determine the sample size. Once we have got that, then we have to see the appropriate test statistic in this case and the sampling distribution. Once we have determined that, then we collect the data, and then with a little addition, after computing the test statistic, we have to compute the p-value as well. And if we see that p-value is less than alpha, then we reject null hypothesis. On the other hand, we then do not reject it if p-value is greater than alpha. So again, we just state our managerial conclusions based on that. After going through this, this is just an example here in which we are taking the same value. We assume that mu is 30, the diameter, the true mean diameter of manufactured bolt is 30 millimeter, and we are given the standard deviation here. And again, we are going through the fact that in H naught, mu is equal to 30. So we are assuming that mean of the population would be 30. So here, on the other hand, once we have stated that H naught in mu is 30, then alternative hypothesis would be mu is not equal to 30. Again, we are taking a two-tailed test. And level of significance here is 0.05 with n is 100. It's the same as compared to previous example. Here again we can see that mu and that standard deviation is known. So now we have to go through the z-test. We have got the same sample results, and here z statistic as before has been computed to be -2. So now going ahead with the p-value, because here you can see that in this case we have got z statistics option here, and here we can see that -2 and 2 both have been plotted, and we have tried to ascertain the probability of z to be less than -2, and that is here 0.0228, and here for greater than 2 it's again 0.0228. So here we can find out the true p-value by adding up the two probabilities, and we get the final one. Now here, once we have ascertained the p-value here, then we can basically judge whether p-value observed is less than alpha or not. So as it is less than alpha, then we have to reject the null hypothesis. So there is sufficient evidence that the mean diameter of the manufactured board may not be equal to 30 millimeters. So this p-value is basically reported a lot, and based on that all the conclusions for the various tests is made. So that makes p-value important. So just having a look at the real-time example of regarding how these values basically of p are reported. So we just try to test the correlation of the two variables called exam and anxiety. So I click on analyze and I click on correlate, and then I click on bivariate here. So we want to find out the correlation between anxiety and exam performance. So just selecting them and entering them into the variable column, and just specifying the two-tailed test. Here you can basically mention whether it's a two-tailed or one-tailed, and again, as we have discussed before, that if your hypothesis is in one direction or in a particular direction, then we can go for one-tailed. Otherwise we would be going ahead with our two-tailed test. So here basically once we have entered these variables, we can click on OK, and based on these results, now we have to basically see that on the first row our Pearson correlation is stated to be 0.441. Now below that is another term which is like SIG, or significance two-tailed, is told to be 0.000. So basically now this is the observed level of significance, and as it is basically less than the expected level of significance, that is 0.05. So basically here we reject the null hypothesis that there is no correlation, or I would say, sorry, we can then accept our null hypothesis here, that there is, that in this case there is a correlation between exam performance and exam anxiety. So basically here the significance is reported in the form of two-tailed test here in every test statistic, and here again, if you can see here, that two sterics are placed on the value of correlation presented here, and it is clearly mentioned that correlation is significant at the 0.01 level. That means that there is 99% confidence level here regarding this. So we can say that the probability of getting the same result from multiple samples is possible in this case, and these values are very much relevant in this case. So this is how SPSS reports the observed level of significance, and it gives us the significance level observed regarding each variable as it is stated here, and it can be given, and it will be given for any number of variables we like in the screen. For example, let's say if we include three variables here, so we include time spent revising as well. So if we just click on OK, but before clicking on OK, you should be seeing here that there's one option called flag significant correlation. By flagging, this means that SPSS will put static marks on those correlation figures which are significant. So that's why those relationships in which the significance is very much good, then we see the statics placed on that, as we have seen in that example. So clicking on OK here, you can see that even in case of three variables, every variable which has been reported has got a significance level mentioned below that figure, and the statics basically represent that the correlation is significant at 0.01 level. But for two statics this is okay. If there is one static, then that means that the correlation is significant at basically 95% or 0.05 level. So this is basically the usage of level of significance or p-value in reality in measuring or in performing any kind of test statistic, whether it's regression, whether it's correlation, or whether it's simple testing of test statistic here in this case. So coming back to our main emphasis here, once we have basically established the 95% confidence interval or level of significance is 0.05, then we can calculate the confidence interval as well. And in this case you can see here that this basically is the formula used to calculate the one end of the confidence interval, which is the main x bar minus the z value and multiplied by the standard deviation and divided by under root of sample. So likewise we can find out the positive side of the confidence interval as well through the same formula. So from these we can ascertain that what are the end limits in which the population mean would lie. So if that limits, if the mean is not lying within those limits in which we have stated the null hypothesis, then obviously we are going to reject it. So here we can see that lower minimum limit is 29.6 and maximum is 29.99. So here based on that we can reject the null hypothesis at level of significance at 0.05, that the mean of the population is not equal to 30. So now basically the hard fact that would you ever know standard deviation, and in reality, as we have discussed before, that no, we do not know the standard deviation of the population, and in reality we are not given the standard deviation in this case. So once if we do know the standard deviation, then in that case the population mean is also known. So basically if we know the population mean, then there is no need to gather a sample to calculate it if we have that figure. So if in case basically the standard deviation is unknown, which is mostly happening, then we use the sample standard deviation sign or notion as S, and here we use basically t distribution or student distribution as well in this case to test the null hypothesis. So in order to use the t distribution, we have to again ensure that the sample follows the normal distribution curve, because these are the basic conditions for testing these kind of normal or abnormal distributions. So all the other basic steps would remain the same here. So basically we know that in this case the t-test, or in that case when standard deviation is unknown, the t-stat is calculated by the formula x bar minus mu divided by s divided by under root n. So this is the formula to calculate the t-statistics. So the test statistic for t formula is different from z-test, and it is typically used when the standard deviation is not known, and basically this is the most commonly used test, as normally we do not know the basically the standard deviation of the population while we are trying to test our various hypotheses. So taking an example for t-test here, we are given an average cost of a hotel which is said to be $168 per night, and now here we are taking random sample of 25 hotels, and basically the mean cost here is 172.5 and standard deviation is $15.4. So we have to test the appropriate hypothesis at level of significance at 0.05. So here we are deriving two hypotheses here. Here one is that mu is equal to 168. An alternative hypothesis here states that mu is not equal to 168. So once we have done that, we come to our same procedure, and here you can see we have determined basically our alpha is 0.05. We know that our sample size is 25 here, and we can find out the degree of freedom by basically subtracting 1 from 25, and that is 24. So as it's unknown, like standard deviation is unknown, then we are using t-statistic, and we have got this formula here, and when we put all the relevant values here, we find out that the t-statistic is 1.46. Now here again, as we have discussed before, that the critical values for the t would be different from that of z. So here we can see that the value of t is stated here for positive side, and for negative the value of t is mentioned here. Now we have to see whether this t-statistic is lying within the non-rejection region here. So here we can see that 1.46 here lies within the acceptance region, and based on that we can say that there is insufficient evidence that the mean of cost here would be different from 168. But again, we cannot basically ascertain based on this fact alone that yes, for sure the mean cost will be different, but we can state there is insufficient evidence, because we are after all taking the value from one sample, and you never know that what result will be portrayed if other samples are withdrawn from the same population. So now going to that, basically this is the general rule that as long as the sample size is not very small, then we can use t-test, and basically we have to evaluate the normality assumption, that how much is the normal test before testing the test statistic. We have to see whether the normal distribution theoretical properties are justified or not. And well, in this case again we have to see that normally the sample size is small or not, but we used the central limit theorem basically in this case, and it states that if the sample size is greater than 30, then it would become normal, or it would portray normal distribution. So the larger the sample size becomes, the more the mean and the other statistics of that specific population, of that specific sample basically, become equal to the test statistics of the main population. So based on that central limit theorem, once we know the number of observations or number of participants, and we know that if the sample size is greater than 30, then by default we can take it that that specific I would say the sample statistic, or in this case the normal distribution here, is normal in that case. So this is a by default rule which is very commonly used, and that would help us in determining the next features also. So anyhow, these are the various measurement errors which we keep on seeing in real-time scenario, and the main thing is that we are trying to find out the difference between actual value and observed value, or the actual value or expected value. So here, as you can see, we try to find out that what should be the ideal case and what is the real case in case what we have determined in t-statistic. So based on that, we can assume that t-statistic is normally used in assessing these various kinds of I would say hypothesis testing. So this was related to our hypothesis testing lecture. So in today's lecture We just discussed the various steps in hypothesis testing, how we have to determine that which test is suitable for testing the hypothesis, how we are to state the null hypothesis and alternative hypothesis, and once we have determined that which kind of test is to be basically made in order to test the data, then we have to also mention the level of significance, and we have to select the sample size, and after that then we can find out the relevant statistic in z-test statistic or whether it's t-test statistic. Once we have found out that specific value, then we have to ascertain the critical values based on which those hypotheses would be accepted or rejected. So once we have done that, then we can plot that specific z statistic or t statistic in that normal distribution curve, and if that value falls within the acceptance region, then we accept the null hypothesis. Otherwise, we have to reject that relevant hypothesis in this case. So we went through these various steps, and then we saw a real-time example of hypothesis testing if the standard deviation of the population is known. So in that case, how we have to basically summarize the present data, and then how to make the null hypothesis and alternative hypothesis in that example, then how to determine the various statistics formulas and their values, and after when we have gone through that, how to compare this z value. And basically after that we discussed about the importance of p-value, because p-value is that value based on which that hypothesis is accepted or rejected. So the p-value is then compared with the level of significance, and the p-value calculation gives us the probability of how much we are confident in getting that figure again if another sample is drawn. So p-value application we discussed with relevance to that in SPSS, and we had a view of how to use SPSS results to interpret whether that p-value is acceptable or not. So we just ran a simple test of correlation, and then we highlighted that how the significance level are reported and how we can say that a p-value is greater or less than to that significance value or not. So once we portrayed that specific example and its application in SPSS, then we discussed about the hypothesis testing example in t-test and why it is used and how this is important, and basically what are the strengths of this test. So based on that, the t-test basically usage was discussed. We took a practical example, and then we formulated the null and alternative hypothesis. After that, once we know that whether the population is known, or population standard deviation is known or unknown, we decided for t-test, and after that then we went through the ascertaining the critical values, which of course would be different from the z values in this case. Once we have done that, then we ascertain the level of significance, and then we can put the values in t statistic to find out the t statistic value. Now this value then can be compared with the level of significance, and based on that we can ascertain whether to accept the null hypothesis or alternative hypothesis. So this was basically related to this whole lecture which we have gone through, and here we are basically experiencing the various methods how this hypothesis is tested. So hypothesis testing basically entails these two main methods, out of which t-test is frequently used, because as we have discussed before, that in the real-time scenario, it is not possible that the population mean and population standard deviation is known to us. So though we have demonstrated one example for z-test, but in reality t-test application is more important in statistics, while basically testing for the experimental data which we may have collected from the field. So based on that we can assess some further applications. In this lecture summary we also and we have basically also discussed about how SPSS reports the p-values, and it is kind of different from the real-time p-values which are reported. So based on that, how to accept or reject our hypothesis, and we just demonstrated about the correlation example, so which was an important example in this case. So this is the main theme, because based on this these steps we would accept a theory or we will reject a theory, because regarding a theory we have different dimensions. So in a study we make several hypotheses to test these different dimensions, and once these dimensions are hold true due to the testing of hypothesis, then we can add up anything in the theory. So that's why this whole theoretical perspective and this conversion of intangible measures to tangible measures is made in order to ascertain that the hypothesis testing is valid, and we have to ensure that this testing is unbiased, so that we can basically say for sure whether the theory which we are trying to test is valid or not. In addition to this value of p-value importance and this hypothesis testing, this should be kept in mind that now the businessmen and the people who are running the organization, their demand is not just testing or giving them the results on the basis of hypothesis testing and on the basis of p-value. So yes, hypothesis testing is used for practically on the sample and trying to see whether a particular hypothesis is true or not. But when the results are reported, then just only displaying the significance of p-value is not enough. And that is why the industrialists and the managers and the businessmen, they require some result in a more elaborate form, which would give them a more meaningful way of giving the conclusion of the results, in other words. So that's why in other words the results are also reported in this form, like that how many standard deviation increase or decrease in independent variable has caused the percentage increase or decrease in dependent variable. So in this form of reporting of results, in this case, gives the businessman or manager or industrialist some kind of concrete foundation of result, and tells them that in reality how much percentage increase or decrease in the profit will be having as a result of some small standard deviation increase or decrease in the variables which are causing that dependent variable. So that's why the typical conventional way of reporting the results of hypothesis testing are not followed now, they are not advisable now. And when you are reporting your results to the organizational managers, then the results have to be reported in a more meaningful and conclusive way. Yes, this is true that the importance of p-value cannot be neglected, and we do have to report that, but simply just testing the hypothesis and reporting the p-value and showing its significance is not significant enough. And in addition, more data needs to be reported in this case. So basically, when we are reporting these p-values, we do have to report the the standard deviation of the dependent and independent variables at first, and show the impact of the independent variable on dependent variable in terms of standard deviation. Secondly, then the impact of the independent variable in the form of standard deviation, and the impact is to be measured in form of percentage increase or decrease in the dependent variable is more desirable. Also, in academia, other than the industrialist part, in academia also the result reporting is now being done in this form. So the way we have just discussed, that we are just reporting the t value or z value, and then we are just reporting the p value in this case, is kind of going obsolete. And that's why the latest trends and latest techniques are basically more advocating for this form of result reporting in this case. Simply just going through the conventional way is not enough. So that's why hypothesis testing is one of the concrete part, and in addition the result formation is now extremely important. The management side is now even not satisfied with this latest trend which we have just discussed, and more concrete ways are being advocated, and which are being pursued, so that we can for sure as a practitioner know that what impact do these numbers in the form of C-test or T-test are being given here in this case. So an industrialist may not know much about these kind of tests, but he is aware of the percentage increase or decrease in the end profits, in the stock earnings, in the stock shares. So if we are reporting our findings in a meaningful way, then in that case that our result would become practical enough in this case. So I hope that this becomes clear enough to you in this whole case, and I hope that this whole hypothesis testing phenomena is understandable to you in this case, because this is a very important part and the foundation of the whole statistical inference, because this is the one methodology through which we are able to test our assumption and can accept them or negate them. And based on these things, and without these, we are not able to concretely present our findings in any way at all. So thank you so much. Take care, and Allah Hafiz.